Hi, welcome back to the class in lecture 4 for Math for Designers. I'm Skipwood Ekvitanipon, and today we are going to learn about linear and quadratic equations. So first of all, this topic would be pretty familiar with you if you went to all the rigorous math. But just for a recap of what are functions, what are equations, and how you solve them. We're gonna have to recap and revisit that. And this lecture is divided into 4 parts. First, we take some recaps about the function. What we mean when we write f parenthesis x parenthesis equals to something. What does it mean? How do you deal with x? How do you replace value of x? Then we will go over the basic stuff of how we compute or how we solve linear equations. And a system of equations in case there are 2 or more equations. And lastly, we will recap the trick or the techniques of solving quadratic equations in 3 different ways, which you can choose the one you like, but usually the third are more general. Actually, let's go over that in that section. For now, we start from the recap for the function. What is a function? Why do we need that? And how do we use it in this class? First, we have what we call the variable. That's a variable. That's something. It is something that can represent anything, or in this case, like any value that we want. It varies. It has many. It has possible values. Like for instance, we usually write as a letter x. X is a variable. X is an unknown. It has some value. We don't know yet, or maybe we don't even need to know. What we usually want to know is that what is its category. In this case, we can say let x be a fruit. X is a fruit. Some kind of fruit. Maybe an apple, an orange, a grape, or anything, any kind of fruits. But we don't know yet. Maybe we don't even need to know. Just keep it unknown, keep it mysterious. It can be any fruit. That's a variable. And it doesn't have to be an X. Sometimes you write it as a Y or a C, or A or B or C, or sometimes a capital letter. It's capital A or B. The way we write sets, right? This can represent a set of anything. Right? That letter A, that capital letter A is actually some kind of a variable. If you don't specify what its value is, A be a set, for instance. And now we have a function. This is kind of like there's a gap between these two, but let's get a recap. And once you have a variable, you can have a function. And this function is a transformation. It transforms, it changes the value of a variable to another value. Oh, sorry. Yeah, it's there. Now, here we use 2 different words here. Like we have a variable, so that's an x, and then to another value. This is sometimes called a variable, but for the sake of simplicity, you call that, you start with a variable, you transform it, you compute or you change or you deduce, get the part, and you get another value. A simple maybe example would be that if x is a fruit, then you can think of a blender as a function. A blender, then that blender blends fruits. If you turn a fruit into a juice, if you turn an x, like a fruit, whatever fruit it is, into its corresponding juice. If you put an orange into a blender, you get an orange juice. If you put an apple into a blender, you get an apple juice. If you put a lemon into a blender, you get a lemon juice? Maybe. Some people call it there, but usually it's lemonade. But you get the idea, right? There's a function, there's a variable where you can put anything inside that, and then you get the output as a different value. And functions can be visualized in two or three main ways. First, this is the formal definition, which is actually what I think this is a bad one to use, but somehow it is in the formal education. It represents it as a set of domain and range. You map one to another. For instance, this orange, yellow would represent that you have a function called f, and you put a 1 inside that, and you get a number 6 as a result. This function transforms a number 1 to a number 6. We will show in a moment that this transformation is denoted in this way. f1 is equals to 6. So we have a set, like the starting part, which is called the domain and range. But you don't have to worry about that word too much. You don't need to go into that much details. So that's how you transform number. And if you ask me what that function is, then sometimes you can describe it in words. Sometimes you can't. In this case, you can't. If you try to see a pattern, why it transforms 1 to 6, I don't know. We don't know. Nobody knows. Maybe just a random pair. You match people, or you match the variable to the output at random. But it works. So that's the formal definition. And later we will see that it is represented in this term, which kind of matches this image. This is a function. That's the name of the function. It starts from A, the left hand side, right to the left hand side, so to the right hand side, to the set B. So that's one way, one concept. It's not rarely used. The next one is as a machine. Maybe this is the more intuitive one. When you think of a function as a machine that takes an input and gives you a print out the output. For instance, if you think of it as a blender, to imagine it as a physical machine, it's a blender. You put inside, right, and out the output. What it splits at the end of the process is the output, or is juice. That should be 2. That's a machine. And X here we call it input. It is a variable. That means you can put any input that allows by the blender, because you cannot put a car inside a blender. Can you? I don't think so, but there's some limit to it about what you can put inside a function. And you get an output as a result. And another way to visualize a function is as a graph. And this is the most common and I would say the most applicable one. Because now we don't just see these numbers as separate numbers lying around on the table. There are 4 numbers on the left, there are 3 numbers on the right. And we don't see it that way. Now we see them as a coordinate between the x. In this case, this is the input. You show the value of x. In this case, we represent it as a line of numbers, of real numbers. where the right hand side is the positive numbers, the left hand side goes to the negative numbers. Then the vertical lines or the vertical axis is the y-axis, which is what we represent as the output of the function. Usually you will see y equals to f of x. This statement or this equation means you compute the output and you put it in the y-axis. Put it in the vertical axis. So we have the input as the horizontal axis, the output as the vertical axis, and then this pink line would represent all the points or the possible pairs of this function. For instance, if you pick, maybe that is not a good function to pick because let's do it here. In this case, you pick x to be 1. Then you look on this line and find a point where the value of x is. In this case, it's 1. And then you look in the other axis, in this case, in the y-axis. If you start at this point and look to the left, and because it's gonna have another scales, 3, 4, 5, and so on. -1, -2, -3, and so on. Now if you start from x, and you go up, you get a point on this graph. And to get the value of this point, or to read the graph, and you look to the left, and then you give you the value of y. In this case, y is 1.5, roughly 1.5. So this point represents two things. First, it represents a coordinate xy as 1 and 1.5. Oh, actually this is in lecture 7, but we'll go into details later. As a point, x equals to 1, y equals to 1.5. Oh, another way is to, you can represent it in the US phase. So if 1 is 1.5. So that's the value of x. And then that's the value of y, or the output of the function. We are going to go into details about graph in 2 or 3 lectures from now. Yeah, but at this point, for now, for the moment, this is another way to view or to visualize a function. We have 3. The first one is very formal. The second one is more kind of practical or tangible. You think about them as a machine. And the third one is what you do almost always in math, which is to make a graph. So that's that in 3 different ways. And for now, we simply view function as the second concept, where you are given a number or a value x, and then you put it into a machine. This machine is like kind of like has a formula on how you transform this input into an output. And this formula is the mathematical formula or mathematical formula. Maybe if you open this machine, you will see inside that, oh, actually it takes x to x squared, for instance. Actually there's a formula hidden in the machine. So we are gonna focus on that for a few classes. And here, yeah, we're gonna get a formal notation of a function. So first we start from that, which is what I used before but didn't define that. Yeah, that's what the function is. So we have a value of x as a variable or as an input, and choose any x you want in the domain. And then f is simply a name of a function. It doesn't need to be an x at f, sorry. You can make it g which you will see if you run out of idea on how to name that function. You can use F, and then G, and then H. Or you can use A. You can use a capital letter. You can write a word like sine of x, exponential of x. All these things are functions. They just have different names. And sometimes if you see a name, if there are more than one letter, that means that it should be important enough that someone gives it a name. Another function. And the way we use function is these three examples. This is a function or a machine. You put orange in as an input. You get orange juice out as an output. So that's three parts. And equal sign means these two are the same. They are equal. And yeah, if you put an apple in, you get an apple juice out. Lemon in, lemonade out. And this is one way to express the function. You can actually like just write one at a time. As a list, if you put this in, you get this out. If you put this in, you get this out. But that's gonna take forever if you have a long list of fruits. If you have all fruits on earth, you don't want to write them all as a long piece of paper. And so you turn that into a short formula, which you said, oh, whatever fruit you give me, and whatever X fruit you give me, the name I will give it to, or the output, is gonna be X juice. Which sounds kind of weird, but anyway, it's something juice. Orange, you put orange, you get orange juice. You put apple, you get apple juice, and so on. And yeah, there are some exceptions. Lemon juice is not common, but people use it sometimes, I guess. But that's the notation of a function. Right? And yeah, now that we have the concept of what the function looks like and how we can use it, and then we move on to the computation part. Oh yeah, this is the first concept. You don't have to read too much into this, but and the formal way to write is to give a name of the function. You start from what is allowed to be an input. What is allowed. In this case, that set is what we call the domain. We only allow fruits to be put into this blender, and not cars and not human. And outputs, usually it doesn't have a. It depends on what your function does. But maybe this is maybe just drinks. It doesn't need to be juice. Maybe it's a broader category. This is what I call range. And you can put what you can put and what might be possible outcomes. And that's the formal definition. But what we need to use in this class, usually N, the set N, the set B can be anything. But in this class, we will focus on the function. Yeah, let's skip that part. We will focus on the function that starts with a real number. Remember this notation? It's the set of real numbers to another set of real numbers. Or in this case, this function or this formula will map or will transform a real number into another real number, which may be the same or not. And for instance, yeah, these are the basic functions you see everywhere or somewhere. You give me a you give me a variable, I give you the output of 4. You give me a variable x, I give you the output of 2 times x. Me a variable x, I give you an output of 3x to the 3x cubed minus 2x. Maybe it's just more complicated. But at the end of the day, this expression should give you just a single number as an output. And that's how we write and imagine functions in this class for this semester. And once we have the name, once we have the shape or what the function does, then we can do what we call evaluate. Can you evaluate the function with a given value? If you by replacing all variable x by the value given. When you given a value, you can throw it into the machine and see what comes out. And for instance, let's just go over the example, maybe that's faster. Like there's a definition on the name. The function f(x) equals to 2 times 2x minus 1. When by the way, when I write 2x, like what it means is 2 times x. Number 2 times the variable x minus 1. Just in case you are not familiar with this notation. And then you can find, this f for various value. So let's write this again one more time. If you want to find f of 2, in this case, it says if you put a 2 into the function, like what is the result? What is the outcome of that function? In this case, by definition, we replace x by the given value, which is 2. So you replace x by 2. There's only one x here, so that's the only place you replace the value. So once you replace everything, you can see on the right hand side, that's just an expression. It's 2 times 2 minus 1, which we can do it by hand to get it to be a 3. And this is how you evaluate. That's the result of the evaluation. You evaluate the function at the value 2, and the result, the output, is 3. And if we change that to 5, similarly, you start from 2. This is what it says, and you multiply that by 5. Let me change the color. Green. 2 times 5. I should put also the small number there. It's 2. Let me go back and rewrite that. It is 2 times 2. That's 2x is 2 times. Wait. I say 5 and I wrote 4. 2 times 5 minus 1. That's what 2 times 5 is 10, 10 minus 1 is 9. That's the evaluation. If you put in 42, what you get out is 2 times what? 2 times 42 minus 1. It's 84 minus 1, or 83. And lastly, sometimes you are given some weird values, but at this point, your job is not to, it's not to do something fancy, and your job is to simply replace every instance or every appearance of x by given value, which is minus pi. You get 2 times minus pi minus 1, which sometimes you can simplify that if you know how to move stuff around into 2 pi minus 2 pi minus 1. So that's how you evaluate these functions. And yeah, that's the end of the first section. So here is the short exercise for you to try. And we'll see you in the next section.